When dividing monomials, the one thing you have to remember is that if your base is the same, all you have to do is subtract your exponents. So in this first problem, we have x to the fifth divided by x to the second. Based on the rule, it should be x to the 5 minus 2, which is x to the third. The reason this works is because you're taking two factors out of the 5 that are in the numerator. So x to the fifth is the same thing as x times x times x times x times x over x to the second is x times x. So you'll see here I'm taking those two factors of x out and I'm left with just the 3 in the numerator. When you have other pieces to this, like you have coefficients, you have x's, you have y's, you just go piece by piece and reduce and take factors out. So what I like to do on this one, we can do it two different ways. I look at the 14 and the 7 and I say, okay, well they're going to reduce to 2 over 1. So 2's in the numerator, 1's in my denominator. I look at this x in the numerator and I look at the x cubed in the denominator and I say to myself, okay, where do I have more x's? I have them more in the denominator. How many more do I have in the denominator? Oh, there's 2 more in the denominator than the numerator. So it's going to reduce to x squared in my denominator. Y squared over y squared, they're going to reduce to 1 over 1 because anything divided by itself is 1. So when you look at this, you now have a 2 up here. You have, this became a 1. This became a 1, so it's just the 2. This is a 1. This one here is an x squared, and then that was a 1. So remaining is 2 over x squared. Another way to do this is to actually take piece by piece and divide. So you have 14 divided by 7 is 2. Based on the rule of subtracting exponents, you have x to the first minus x to the third. So 1 minus 3 is x to the negative 2. And then y to the second, so this one minus, with this one y to the second, so 2 minus 2 gives me y to the 0. And then you can evaluate this expression here. So 2 over 1. To make x to the negative 2 a positive, we take x, 1 over x squared, and then we know any number to the 0 power is 1. So this is going to just become 1. Then always put it back together. So 1 times 2 is 2 over 1 times x squared is x squared. So there's two different ways to think about this. I like to reduce within as opposed to breaking it apart and dealing with negative exponents. So this next, to reduce it within, you have 3 over 6, which the 3 becomes, I'll use a different color. That becomes a 1. 6 becomes a 2. Then I say to myself, okay, I have more x's in my numerator than my denominator. So I have x to the fifth, x to the third. I have 2 extra up here, so x squared. I have y squared, y to the ninth. So that means I have 7 more factors of y down here. So y to the seventh. And then I have z here and z to the fourth. I have 3 more z's down here, a z cubed down here. So all these became 1 again. So 1 times x squared times 1 just gives me x squared in my numerator. So x squared over. And then I have 2 times y to the seventh, z to the third. So x squared, 2y to the seventh, z to the third. Okay, and that's in its simplest form. So this last one, we are dividing, and then we're taking that monomial to the third power. So you could either distribute this 3 to each piece first, numerator and denominator, or you can simplify within first and then evaluate the third to the third power. So when I look at this, I can see I have got x to the third, x to the fourth. I'm going to simplify those first. It just makes everything easier when you simplify. So this will become 1 because I've got 1 extra x down here than I do up there. So let's just rewrite this. So in my numerator, now that I simplified it, I have y squared over 2x. And I'm raising that whole thing to the third power. Anytime you raise a power to a power, you multiply your exponents. So in my numerator, I'm going to take 3 times the 2 to get y to the 6th over, I have to distribute this 3 not only to the 2 but also to the x. So 2 to the 3rd power, okay, so 2 to the 3rd is 8, x to the 3rd. Nothing can be reduced, so it's in its simplest form. So when you're doing these, you can take a look at it and you can actually subtract your exponents like we did up here. Or you can think about it as, where do I have more factors? Is it in the numerator or the denominator? And simplify it that way.